presentation.
Great, thanks, Allison. Excellent. Next slide, please. So, well, actually, back up one slide. I'm sorry. Let me start a little bit higher out. So, for this set of slides in particular, wanted to have use this as an opportunity for real grounding and a starting place. So, depending on how much research and background and time in electric buses that you have, some of these things maybe some you already know, some maybe things you don't, and this is again really intended to be a starting place and a grounding point. So we plan to have more of this or more available. But that said, if there is a particular question or topic that we don't address, please ask. So even if it's not covered in here, please feel free to ask, and we can spend the time that we need to go into the level of depth. And our goal here is to, I guess, now we can, next slide, talk a little bit about CTE. Next slide, please. So we are a nonprofit 501c3. We're a little unusual in some ways, though, that we are primarily technical engineering staff, and we primarily work really kind of sleeves roll up in the nuts and bolts of actually getting electric vehicles out there and working with project partners to make them successful. Like to sort of use a restaurant analogy that if you go to a bad restaurant, you tell 10 friends, and you go to a good restaurant, you tell one. So it's really easy to share stories when things don't work well. And so as part of our mission and our drive to really accelerate the adoption, real world adoption, and get electric vehicles on the road and have them be successful, we see that as our role to help in some sense level the kind of information playing field from the manufacturers, but also really provide a place and way for folks to ask questions, and also really get into the technical details as needed. There's a number of considerations that are different from conventionally fueled vehicles over to electric. So we have been working in this space for I think 28 years at this point, and have worked on over $500 million worth of projects, and again, almost primarily all electric vehicle development and deployment projects in that time. We have 4 offices, but do projects across the country. Next slide, please. Right. And then just as a note, so we do have a number of projects. These are not all school bus projects. The majority of these are in the transit world, but do have more in the school bus market is accelerating quickly. So that's something that's really excited to be doing more of. But I want to share that we have 4 offices, but we really do work across the country, including a number of projects in the transit space in Oregon. Next slide, please. So one of the first questions that I want to address is that how, sort of why, I guess, is the first question, and also why now. And some of these may be pretty familiar, but just wanting to, as this can be a challenging process, really, why, and how, and what's the drivers here. So the main one, of course, that is the biggest driver is this zero criteria emissions around vulnerable populations. Of course, there's an asterisk there with diesel fired heaters we can talk a little more about, but they do have the ability to dramatically reduce emissions impact. And the flip side of that, of course, new vehicles are much cleaner than old ones, new diesels. So there's also the question of domestic fuel production, and lowering the use of oil, lowering, or if you have a zero emission energy source, potentially eliminating greenhouse gas emissions. I say hopefully now for lower lifetime costs. We can talk a little more about that. down the road, I'm confident that electric drive really is the future. This is a question of when, but not if. There's also a lot more funding availability that is available today to support these new vehicles, and I'd say that a good confluence of positive factors on the vehicle side as well. And this is building volumes in battery production that's driving down costs. Electrification in other sectors, which allows for kind of parallel efforts and volumes of scale, which is really helping bring the vehicle availability over and becoming more so vehicles with fewer compromises. So it's not that electric vehicles have always been possible. Really primarily a question of range and how far can they go. So now we're getting really closer to much easier and general purpose vehicles. So next slide, please. So just little electric bus history. So this is certainly not comprehensive because there are a lot of buses on the road today. But in 2014, Kings County had the first all electric school bus approved for student transportation. There were some prototypes earlier than that, but this is sort of a out the door and operating in a kind of general service. Next slide. And then in 2017, I use this locally because Minneapolis area got their first electric school bus, which as far as I can tell from talking about the operator, has really been quite positive experience. And then more recently, something that made a lot of news is Montgomery County signing an agreement to get, I think, most accurately, I'd say up to 326 vehicles, but really starting to see, potential here opening for much broader adoption, and really having deployment starting to really become much less theoretical and much larger numbers. Next slide. So this is this information is 2019, so a little old, but I think I want to show that, of course, primarily the most vehicles are gasoline and diesel. I know the percentages. Look at the height of the bars. I guess it's not the. I know the percentages add up to more than 100. But as as of even a little more than a year ago, having 3% of the vehicles sold be electric is really pretty interesting. That's a dramatic growth, and I know I think that percentage is only growing, as is the interest. So much like I think the adoption of wind and solar, is already picking up steam, and I think will continue to do so. Next slide, please. So
Eric, you just muted yourself.
Oh, thanks. I don't know how I did that. Thank you. Okay, thank you. I don't know how I did that. Thanks. Neil, it wasn't for long, was it?
No, you just switched to this slide and then got muted, so you're good to go.
Okay, thanks. I don't know how that happened. Thanks. Yeah, so there's I think 300. I think that number actually may be closer to 400. It's actually hard to keep track because it's moving very quickly at this point, and with a whole lot on order. So certainly California has the greatest number of those, and of course I think this is primarily a question of where the funding's available. There's a lot of interest, and really a question of funding. So and I guess if I didn't say at the beginning, please feel free to ask questions either along the way, or if we get to the end and there's something you're hoping to get to, feel free to ask. Next slide, please. So I want to talk a little bit about some of the primary differences between diesel and electric, and from as really a comparison of the fuels and how are these really different, because diesel or gasoline in this case is very familiar and has a lot of certainly benefits and drawbacks. But diesel is very easy to store as a fuel for kind of off hours use and filling. Electricity is difficult to store. There's a couple ways, but aside from batteries, is actually very difficult to hold on to. So I'd say I'd give diesel the edge on storage there. As far as delivery, diesel is delivered by a truck or pipeline sometimes. Electricity is delivered by a wire. I'd call those about even. Really not much different. Diesel certainly has in all parts of the country, including the grid itself, diesel has a higher amount of pollution and tends to be getting worse over time because of the oil sources that are getting more and more difficult to find. Electricity is a lower pollution energy source today, and with the addition of more wind and solar as time goes on, tends to get better. So definitely the edge on the pollution to electricity. When you purchase diesel, that's very straightforward. You purchase gallons. When you purchase electricity, this can be purchased in. It's important to know the volts it comes in at, the amps, how quickly, kilowatts of demand, and sometimes this can be kilovolt amps, and the number of kilowatt hours you produce, which is a potential dramatic increase in complexity, at least in thinking of this as a fuel, and also as potentially everyone has an electric bill. The electric bill resulting from a electric vehicle deployment will be larger and potentially in different rate structures than the kind of a regular bill you might be used to. And then same, of course, it goes on how you pay for it. Paying for diesel is easy. How you pay for electricity can be more complicated as well. Next slide, please. So the most important thing when thinking about energy on board is to really think about when you see that kilowatt hour number for a battery, think about that as gallons of diesel. Those are really, how far you can go on a kilowatt hour and how far you can go on a gallon of diesel are different, but really, think of them in the same terms. Anywhere you think of diesel, think of kilowatt hours. So next slide. Okay, so we have 3 potential electric energy consumers here. So quiz. So which of these uses the most energy? A 60-watt bulb, of course, an old, not an LED bulb, a battery electric bus, and a 1.21 gigawatt flux capacitor. So to the crowd, which of these might use the most energy?
Feels like a trick question. I'm afraid to answer, but I'll bite. How about the old school bulb?
Yes, your instincts are right. So next slide, please.
That's amazing. So
yes, there's not enough information. So in some sense, that really is a trick question. So in order to know how much energy a bulb uses, how many hours, how long, 60-watt bulb running for a year uses actually a lot of energy. On the battery electric bus, how many miles did it go, or how, what was the charging like? And on the flux capacitor, I guess how many times was it struck by lightning in Back to the Future? But it's an important discussion, and I bring this up because the terms for measuring and paying for energy are at one point very familiar. These are all units that everyone uses to purchase things, and when I say things, that can be light bulbs to buses, but kilowatts, kilowatt hours, and watts and volts and amps are, again, they're all familiar, but some of the implications and understanding what those mean can be a really important distinction in thinking about energy use and consumption, and that gets into both costs as well as your needs. So next slide, please. So I want to talk a little bit about batteries themselves. In my opinion, one of the main reasons we are even having conversations today about heavy-duty electric vehicles is advancements in batteries. Electric drive systems to move a vehicle down the road have existed for a long time. And otherwise, a lot of the parts on board an electric bus compared to a conventional are largely the same. There have always been batteries that could move a bus. Really, the advancement is batteries that can store enough energy at a light enough weight that are cheap enough and have all of those factors come together to make it possible, I guess, to have a vehicle for sale at a price that works, that actually accomplishes the mission. So, want to talk a little bit about batteries because they are sometimes just kind of assumed. And again, happy to go into as much details as folks want to hear about batteries. Next slide. So, mentioned this a little bit already, but to reinforce, you'll see these terms used and sometimes a little interchangeably, but a kilowatt and a kilowatt hour are very different things. So even though they again are sometimes used and putting on my engineer hat, used incorrectly, interchangeably, they measure very different things. So the best way to think about it when you see the word kilowatt is that think of that in the same way as horsepower. So that can be, this battery can provide, or this motor can push you forward with 300 horsepower. So that tells you how quickly you can do something. Alternatively, it can talk about charging rates. Again, it measures how quickly something happens. So your charger might be a 50 kilowatt charger. In comparison, a kilowatt hour is the best to think of as a gallon of diesel. So a bus can have 200 kilowatt hours, which from a comparison standpoint is, not sure my math is right there. I think that's closer to 8 gallons of diesel. But anyway, a much smaller number. Trying to do the math in my head anyway, but yeah, a much smaller number in terms of energy on board, and that of course is one of the key drivers for understanding the main operational and kind of energy difference. So yeah, next slide, please. So as a simple view of a battery, a lot of times you'll hear a vehicle sold or some sort of something that you're purchasing will have a certain size battery. We typically will call this the nameplate capacity. So oftentimes, if you purchase a bus and it has a 200 kilowatt hour battery, that is what I would call the nameplate capacity. So this is challenging because you don't actually get to use all of that energy on board. So when you're thinking about how far you can go, or potentially how much you need to recharge or how much energy you might consume in a day, you don't actually have access to all that energy on board the battery. And for better or worse, this is a little bit the way the industry is. So next slide, please. So a more realistic view of the battery is you have to cut off in the neighborhood of 20% of that overall brand new battery that you don't get to use. So the very top end of the battery, you're not allowed to use typically because it really accelerates the loss of lifetime in the battery to charge the battery up to its theoretical maximum. So you don't ever really charge the battery up to its kind of theoretical full state. And then on the bottom end, in lithium ion batteries, which are really what is everything in a heavy duty vehicle today, have a really pretty reliable performance over their whole energy. Some, if has experience in like an electric forklift with a lead acid battery, they do tend to get sluggish towards the end. A lithium ion battery tends to be pretty usable and stable until you get quite low. And once you get quite low, the ability of the battery to push out lots of power becomes limited. So typically you'll have kind of a area of kind of derated performance. So the vehicle will still move, but you may not have access to all the power that was there. And much like on the top end, for some different reasons, but ultimately much the same idea. in order to protect the battery and its longevity, you're not allowed to use the very bottom theoretical amount of energy in the battery. So, here's the more realistic view is that out of that 200, you get to lop off 20% typically. Excellent. Any questions on batteries? Not quite done with batteries, but happy to pause for a second.
So Eric, a question there, and how bus manufacturers market these. That usable range in the middle, when someone explains the range of their bus, that's going to be based on the usable range in the middle, right?
Yes, and so, well, hopefully. I think I could say I've seen it all. I do think the school bus world is a little more honest in some ways, but I've definitely seen it both ways. But if someone is quoting a usable range, it should only take that middle part into account.
And then some manufacturers will list the full nameplate range, and some will just list the usable range when they're talking about the battery capacity, or do they all list the full battery capacity? I know on the passenger vehicle side, it depends on who you're talking to.
Yeah, I think for the most part, when they're talking about a usable a range, and you can't see my air quotes, but a range, that is typically around the usable part. Sometimes where that can cause confusion is if you look at kind of a claimed efficiency and the total battery pack size and the range, you'll find those numbers just don't all connect to each other. And this reserved battery capacity can be the reason for that.
Gotcha.
And then, yeah, I'll come back to range in a little bit, but yeah. Good question. Any other questions? Great. Next slide, please. So one of the really most fundamental differences on kind of expectations and thinking about a battery electric vehicle is the battery itself does lose capacity over time. And it's I wouldn't say it's really a feature or a bug. It really is just sort of how batteries work and how they operate. So as a battery ages, you'll lose again 20% typically. Once you've lost 20% of that initial capacity is typically when a battery is considered end of life. Now, as long as the vehicle still meets your needs, if you have routes that are all shorter than that, the fact that the range is reduced may not have any impact to your operations because you can still meet your needs with that reduced range. So it's not that the vehicle doesn't work with the reduced range, but just that if you have a vehicle with a new battery and is barely accomplishing it, know that as those batteries age, that will get increasingly challenging. So. Battery degradation is a pretty big topic, but any other questions or thoughts on degradation? Excellent. So next slide, please. So with that in mind, so I guess maybe I'd like to turn this over for folks to shout out. Any ideas on what some of the factors are that cause batteries to age?
We have 2 EVs at this point in my home, and I'm pretty sure that just using our car, which we're supposed to do, causes our batteries to age.
Mm-hmm. Yep. Thoughts on other factors? Okay. Glad I couldn't. So short answer is everything. Everything causes batteries to age, and in different amounts. And I don't put this up to be trying to dissuade anyone from batteries, but more to be kind of realistic or understand, what some of the factors are that lead to that loss of capacity. So certainly there's a calendar age portion. The rate that you charge and discharge, so sort of how the battery is used, can have an impact. Sitting at very high temperature can have an impact. Battery thermal management systems should take care of that. How deeply you discharge the battery, that's the cyclic depth of discharge, but how deeply you discharge it can have an impact. And then from, I would say more as a storage standpoint, being stored at very high state of charge or a very low state of charge can also impact the life of the battery. So oftentimes what I'm asked for at this point is, well, then, what do we do? Or how much do we worry about these things? Or how do I use a vehicle if I have to worry about all these things? So my conventional answer there is, use the vehicles as you need to for your operations, because that's really what the vehicles are for, is accomplishing a need. In this case, transporting students. So use the vehicles as you need to. And then that's the, once you have the vehicle. And then the other side is ensuring that you have good written warranties for what happens with batteries as they age, because again, it's something that will happen, and having a clear understanding with your manufacturer, if there is a remediation, how is that triggered, and how does that process actually work? So next slide, please. And then one of the other questions we get a lot as well is, gosh, I heard about this excellent battery. I read about it in the newspaper. General Motors is moving to their Ultium platform that's going to change everything. And the shortest answer is there's a lot of press release jockeying that happens in the battery world, and the reality moves much slower than the press releases. So the whiz bang thing that you read about that's going to change the world is probably the size of your thumbnail, and it works, but probably not for very many cycles. So there's a long gulf between those very early prototypes and a manufacturer putting their faith in it, integrating it into a vehicle and selling it to their customers. So all that said, there is a tremendous amount of money and innovation in batteries right now. So they will get incrementally better every year. And I think in the next 10 years, there will be some transformative technology changes. But I don't recommend waiting waiting to move until the next thing comes. So next slide, please. One of the questions also we get a lot about is safety. First off, any energy source, fundamentally looking at it, that can move something as heavy as a bus in the wrong situation can lead to a hazardous situation. So that is really something of more of a fact of life. It is possible. All that said, the battery management system and system design it is really one of the most important things. And yeah, I guess this is a really big topic. So I guess maybe I'll pause there and see, from a safety or concern standpoint, if folks have kind of separate questions that I can help address there. Or
Chris, I remember from last week, it was at least Klamath County, maybe it was your district too, that had been bringing in propane within the last several years. And of course, that has different, safety protocols than diesel and gas. I'm just wondering whether you or others in the group have safety concerns about electricity, because usually people do.
I did have some concerns because of the high voltage. Is there a shielding for those battery packs? I mean, I'm sure there is, but can you describe that?
Yeah, so typically there's standards around how the containers are built. So that's certainly the sort of mechanical packaging is a really important part of the safety and design. There's also the high voltage system runs completely separate. So if you're familiar with the electrical system on a 24-volt vehicle, you know the chassis is the ground. That is not the case with a high voltage system, so they run completely separately. And there's also typically a system that looks for a ground fault, kind of similar to a ground fault detector on a GFCI outlet, but looking for a connection between those high voltage system and the chassis that shouldn't be there.
Okay. What's involved with servicing that type of system?
Great question. So with a lot of times with initial vehicles and first deployments, the greatest hazard is inside that battery enclosure. So inside the battery enclosure, you have no way to remove the hazard. You know, you have live voltage, and if you touch the wrong two places, you will get shocked. So inside the battery enclosure is, I would say, the highest risk. And a lot of times the manufacturers really don't want you in there. I think, and I'm pretty supportive of that, because there's that really is the greatest hazard and the hardest to mitigate. So outside of the battery enclosure, you'll have switches and contactors, some typically automatic and manual. And a general electric vehicle safety protocol is to put on, if you are doing maintenance on a high voltage system, to put on personal protective equipment, put on PPE that's rated to handle the power. So this will look a little bit like electrician's gear. So that's high voltage gloves, and an apron. And confirm that there is no high voltage present. So once you have confirmed and gone through a lockout tagout process to confirm that the high voltage is really contained inside that battery container, at that point, you're free to do maintenance without PPE, because there's no hazardous voltage present. So one of the nice things about electricity is that if once you confirm that it's absent, it isn't there, right? There's no fuel line to puncture. It is really locked inside the battery. Did that answer the question?
Yes, thank you.
Excellent. So I know safety is a really big topic. Other safety concerns, or broadly about either electricity or the buses?
Eric, have there ever been any reports of a real disaster and injury? Any injury reports around electric buses in your tenure?
Good question. I am not aware of injuries. Yes, on property damage, specifically on the bus, which is pretty rare, and I believe less common than their fossil fuel counterparts. But I don't think I'm aware of well, maybe not on battery electric. Actually, I think I have heard some stories potentially on hybrid system maintenance. So diesel electric hybrids, which actually have much the same electrical hazard as a battery electric, pure battery electric bus. So I think there may have been some incidents with hybrid vehicle maintenance.
Thank you.
Yeah. Great. Next slide, please. Great. So I want to talk a little bit about, what's new and what's not new. So a lot of the parts on, like, if you have a Bluebird diesel and a Bluebird, well, I guess maybe I shouldn't speak specifically about Bluebird because maybe things are different. But generally speaking, in most vehicle systems, a manufacturer really has a strong desire for consistency in parts on their side as much as you might as well. So so they really want to use those same parts on their conventional vehicles as well as on their electric counterparts, and that can go as well for the manufacturers that are solely building electric buses. They'll want to use axles that folks are familiar with. So the things that are different, so heating and air conditioning can be electrically powered. You'll have accessories like power steering and the air compressor. Of course, the drivetrain itself, that's really what people talk a lot about: motor and batteries, and then the charging interface. But brakes, air systems, seats, doors, a lot of the other parts that you may be familiar with. If it's not on that list, it's probably very much the same. Next slide. So from the electric drivetrain, really to say what this is, when I say drivetrain, the key parts, if you look at the picture on the right, you have an electric motor, which is kind of right centered where the three wires are feeding into. So that very much replaces the drivetrain, a conventional motor. What feeds that is what's called the motor controller, sometimes a motor inverter. So the motor inverter's job is to take the power from the batteries, which is shown here on the left side, take the power from the batteries and turn it into a usable power signal that makes the motor work. And then an important part of as well is the brains of the system, called different names, but vehicle system controller. So this accepts the inputs from the driver, watches the conditions in the battery, watches the conditions in the motor, and make sure everything is functioning and safe. So next slide, please. A few electric school bus OEMs listed here. There are, I think, especially in maybe some of the smaller Type A ones, there may be some more. These are really some of the main ones. I'm sure there may be more coming. Next slide. And then, as mentioned, we're a nonprofit, so if there's we work in a variety of roles as folks need to help support a zero emission vehicle future. So there's a number of things listed here, but guess if I'd like to maybe turn over to just talk about just general questions. I know it's a broad topic and there's a number of things that didn't get to. So maybe I guess Allison, let you watch the clock, but as many time for as many questions as we can.
So I think that Neil is going to lead the Q&A. That's kind of a specialty of his.
Awesome. That was really great, Eric. I feel like I always learn something. And this is an open opportunity to ask questions for everybody that's in attendance. So feel free, if you have a question, to type into the chat, raise your hand, or just unmute yourself. And I have a couple of questions teed up as well. So just that came out of my own curiosity. So feel free to ask questions if you think of them. One question that I had, Eric, was in terms of, and I think we'll probably do a webinar in this in the future, but in particular for folks interested in their first deployment of an electric bus, when someone's interested, they might see some funding coming down. Infrastructure wise, how would you recommend somebody starting the conversation of figuring out if they have capacity for, or how they start the conversation about their bus yard and infrastructure?
Yeah, good question. So I think there's really two, kind of maybe a fork in the road of how to think about this. One is, hey, we're getting a bus. What do we do? or how do we start? And then there is the question, which is to me a very different question of, we're thinking about getting 15 buses. What do we do? Or we're thinking about a large number. So I think those questions need to be thought of very separately. The 15 buses is almost certainly going to be a new electric service of some kind. But if you are just looking to get a bus, and you can probably get an AC charger. You probably have somewhere on your yard that has or a panel with electrical capacity to support a what's called a 70, a level 2 AC charger. And you can probably fit one. So if the stars align and you're able to get a vehicle, I think it's probably pretty likely that you have some available existing capacity to support one of those. But supporting 10 of them on an existing circuit, almost probably not. And then you're looking at new service.
And then, once and I see your hand, Lisa, and we'll jump to you right next. Once you do kind of get into whether you're starting that way or whether you already have one bus and are looking at expanding, how long do you think a district or transit agency should expect those conversations of additional service and infrastructure to take? Like, how long would that planning process be for an agency?
I always like to put kind of a round year around infrastructure questions. Things always seem to take longer than you think, but I think a year is kind of a nice number. Sometimes school buses actually can move pretty quick, so definitely watch out for that. But yeah, around a year roughly. If you need a service line potentially from the utility, you need to get the engineering and contracting, design, and installation done on a new service and chargers, and to figure out what your service needs are. So that I think and then also depending on always need to think about internal approval processes and funders or boards of commission that might have to approve things. So all those steps have time.
Great. Lisa, it looks like you had a question.
Yes, and you somewhat, may have answered it. When you said before, there's a difference between we're going to add one vehicle or two, and you could use your existing service, to we're going to add 15. We are going to start with just, one or two. Well, 2 is what's planned, but then go to 4 fairly quickly. As we look, if there's a point at which we go from 4 to 15, that period to get from the service we have now to the service that we would need for that's the year that you were just talking about, correct? Or are there any other complications between making do with what you've got and moving to what you need?
So aside from a potential, maybe duplication of effort or copper, you may have some sort of stranded assets from the first one that you may not be able to bring over to the second. I'm not sure. If the future service fits your needs, then I think you're in good shape. There's always a question of whether you need to move everything over to the new service or continue to use those, maybe what I call temporary or starter ones. Sometimes it makes sense to keep them around. Sometimes it might make sense to unbolt them and bring them over to your new service. Sometimes you might get a better rate on a kind of a dedicated EV service. I don't, like I said, except for potentially sort of a stranded asset, I don't know if there's anything to go wrong.
Okay.
But I'm nervous to say that because I'm sure there's something. I'm just not sure what it is.
And it wouldn't change. Like, we can't start with 8 or 10, or we this is how we have to start. So it just is what it is. But,
Mm-hmm.
yeah.
And I'll also add, sometimes when you start mapping things out in a yard, you can see the opportunities for where there can be some small wins, so you don't end up with stranded assets. So if you are doing any trenching as a part of a project, thinking about where that further service is going to be, running conduit ahead of time, there's some inexpensive pieces early on that sometimes can work out or if you're building a new facility, that you can make sure to minimize those costs going forward. And that reminds me of, I think it was, I don't remember if it was Mike or Chris that is joining and had questions about a future facility. So Eric, if somebody is moving, do you have advice on how to think about some of that make ready ahead of time if you're planning a bus yard from ground zero?
Yeah, good question. So the I guess you brought up conduit, Neil. That's a really important one. If there is any opportunity to get conduit in the ground, that's always one. One way, if you're building a site, maybe not, is sometimes you can do trenches, like covered trenches that you can lay conduit in the future. This can be an option. And then I think really the next thing, if you are kind of moving over to a new facility, is to take the space constraint or the additional space of the chargers and some of the hardware into consideration. So all of these chargers have to be somewhere. So sometimes that's not a big problem. There's an obvious place, maybe vehicles pull up to a wall and you mount the chargers on the wall. Sometimes in really packed bus yards, that can be a real challenge. So thinking about where the physical infrastructure will go can be something to try to do right the first time. And then I'm trying to think. I'm not sure what else in the absence until you're actually putting stuff in the ground, what you can do fully ahead of time.
I could just speak from some experience of people. Asking the question is really important. So I can speak from somebody. I was working with actually somebody from ODOT here in Bend, and they were looking at just putting in some passenger EV chargers. And as a transportation organization, they were asking the same questions. I don't remember, 7 or 8 years ago when they built their facility, and they weren't planning on putting in charging at the moment, but they had the foresight to run that conduit, and the ease of the lack of complication and the cost of adding charging was so inexpensive for them compared to every other person that I talked to. So it really can pay dividends, and is important to keep in mind. Especially, sounds like on our bus tour that we went on last week, there were a lot of agencies that were space constrained, thinking about expansion or moving in the next few years. So it's good factor to include. Other questions? We probably have time for one other question if anybody has anything specific.
I have to jump out. I have an 11 o'clock meeting, but thank you.
Yeah, thank you so much, Lisa.
Information, and I'm sure I'll see some of you, if not all of you, again.
Yes.
Yeah, definitely.
Thanks, Lisa.
Very good. Thank you.
Thanks, Lisa. Yeah.
I'm going to go ahead and wrap up. And one of the things I wanted to share about our electric bus learning project is that we just completed the first ever electric school bus tour of Oregon. I got to meet Chris on that tour in Klamath Falls. Didn't get to meet you, Mike, but maybe next time. And Brock, I know, has experienced electric school buses before, including driving one, as I recall. So people were really engaged. Let's see, there were 10 different school districts in 7 different stops, and about 150 different people got to drive it. I saw Chris drive it. Mechanics are involved. We got it up on a lift. It's fun to see underneath the chassis and see the electric batteries. The more that people can experience an electric bus and be included and involved in the development of any bringing in an electric bus, usually the more successful it can be, because people need time to adjust to change usually. So that's the latest thing that our project has been working on. We're going to have more events coming up both this spring and this summer. We're also going to have an electric bicycle ride and drive in at least 2 different cities come September to get more young people involved. Is there anything that I have forgotten in terms of a wrap up? You'll receive another electric bus newsletter soon. Is there anything, Neil, that I have not told people that should be expressed.
I think just that some of our next resources that we'll be sharing later on in June, we'll be talking about funding cycles that'll be opening up. And so
Funding.
that question that comes up often, make sure to stay connected, because that will be the next topic that we're planning on diving into as a group.
In particular, and this is especially for Chris and Mike and Brock, I'm sure will be involved kind of, at least as an onlooker, Volkswagen money from Department of Environmental Quality, DEQ. Electric school buses will be eligible in this next round. And this, it's a funding proposal period of June 30th to August 30th. And our project will be able to support people as they apply for funding. And I can share that link in my next newsletter. So hopefully we'll get some more funding for some more electric school buses. I think we're at a close for now. I'm glad that people have come, and always feel free to give us feedback on what you need more of or less of, or what you'd like us to keep doing.
Right. Thanks, everybody.
There you go.
Goodbye.